Okay, yesterday in your class, we finished up the front side, which was using the discriminant being b squared minus 4ac, to help us decide whether each conic section was an ellipse, hyperbola, or parabola. And you guys said we got through all of them just fine. Okay, so today we're looking at the backside. And the backside is, okay, how do we graph these? Not how do we get them in the standard form we've been getting them in the other sections, but how do we graph these on the graphing calculator? And so you guys know at this point of the year that to graph on the graphing calculator, it has to be y equals. And that's going to be the challenge in some cases today. And so the goal is to solve for y, so we can type it into the y equals. Completing the square is an option today. Again, it just kind of depends on what is there. So as we look at example A. Example A, 9x squared plus 16y squared minus 18x plus 64y minus 71. And the big thing here is, what do we have in the way of y's? Because that will always kind of decide how we're going to treat the problem. Excuse me. And in this case, what do we have in y's? Yeah, we have a y squared and a y. If we just have y squared, or if we just have y, we can solve for that. Since we have, when you see y squared and y, that usually leads us to complete the square. Okay, so we're gonna get that out of the way right off the bat. In that, we are going to practice our complete the square. Okay, so if we're completing the square, we're still solving for y, right? So first step, y squared and y is on the left. Everybody else, move to the right. So I'm going to keep 16y squared and 64y on the left. I'm going to leave a gap. And then I'm going to move everybody else over. So I'm going to subtract 9x squared. 16y squared is already there. I'm going to add 18x over. 64y is over there. And I'm going to add 71 to the right. Are we okay with that? That is me trying to get y squared and y by itself. Or all y terms on the left, essentially. Now, before we complete the square, what has to be true? It can't be a 16y squared. It needs to be a 1y squared. And if it's a 1y squared, depends on the situation. If everything's going to divide nicely by 16, I would consider going ahead and dividing everybody by 16. But this right side is not going to divide nicely by 16. So I'm going to take the factoring method. I'm going to factor 16 out. So if I factor 16 out of the left, I'm then going to have y squared plus 4y. I'm going to leave a gap before I end my parentheses. And then on the right, negative 9x squared plus 18x plus 71. Yes?
So would we not want to make it 16y outside of the parentheses and then do it?
No, you do not want to factor out the GCF of y because then we can't complete the square.
Okay.
We want it in that form of, normally I say x squared plus bx. In this case, we want it in the form of y squared plus by. Okay. You guys are still a little trained to factoring. That always pops up. Yes?
Okay, so if we were like just say that the right side would divide like nicely by 16, we still divide that 64 by 16, correct?
Yes. Yeah, if the right side would divide nicely by 16, you would just have to divide everybody across the way by 16. So, okay, we ready to complete the square? In order to complete the square, we're going to do half of b and square it. What is my b? 4. So 4 divided by 2 is 2. 2 squared is 4. I'm going to add 4 on the left. If I add 4 on the left, okay, we're going to add, quote, 4 on the right, but it's not just a 4, it's a 4 times 16, because there's that 16 multiplying. Anytime you complete the square, the whole purpose of that is we now can factor. So I'm going to keep this 16 out front for right now. I'm going to factor. Square root of y squared is y. The square root of 4 is 2. That's a plus 4y in the middle, so I'm going to say y plus 2 quantity squared equals, I'm going to clean up my right, it's negative 9x squared plus 18x plus 135, if I recall. 71 plus 64.
Yeah.
Okay. What's next? Working to solving for that y. I wouldn't take the square root quite yet. I would get the 16 moved over. How do we move that 16 over? We're going to divide. So if I divide the left by 16, it just becomes y plus 2 squared. If I divide the right by 16, it's not looking very pretty for dividing by 16, is it? So I'm going to make it one big massive fraction. Negative 9x squared plus 18x plus 135 all over 16. No one said it would be pretty. Again, if it all divided by 16, I would. I would love to not have that ugly fraction.
But it doesn't matter because we're just typing it into the calculator.
Right, and that's the thing. Yeah, we are just going to type it into the calculator. So if it's y plus 2 squared, next step is to take the square root. If I square root the left, I'm square rooting the right. The square root of y plus 2 squared is y plus 2. What's the square root of this right side?
Just the square root. Plus or minus.
Plus or minus the square root of all that stuff. So negative 9x squared plus 18x plus 135 all over 16. And if it's y plus 2, I'm going to subtract 2. If you recall what I've done in the past and what I prefer to do, is I'd like to say y equals, and I'm going to put the negative 2 out front, say negative 2 plus or minus that big square root. Negative 9x squared plus 18x plus 135 all over 16. This is one possible way to type it into the calculator. If you do this, your entire fraction is under the radical, yes? Now, and I'm fine if you leave it like that. What's another option? What's the obvious here? What do you notice about that denominator of 16? It has a square root, yes? And so another way to put this is to still say y equals negative 2 plus or minus, but you could take the square root of 16 to be 4 in the denominator, and then you only have the square root in the numerator. So the square root of negative 9x squared plus 18x plus 135. That's what you'll probably see me write more often. Again, we're looking at equivalent forms here. If you want, I could show you one more. Oh wait, do I really want to say if you want? I think I'll show you one more. Honestly, this one I just did is probably the best for you guys. But what do you notice the coefficient of x squared is? There is a 9, yes? And what do we know about 9? It has a square root, right? Square root of 9 is 3. Now, that only matters if, is 9 a factor of every piece in the numerator? 9 divides into 9. 9 divides into 18. Does 9 divide into 135? It does. 15, yes? So, another option. And again, I'm not saying you have to do this. I'm just saying it's an option. I'm going to write it down here because I don't need as much room in the next problem. But another option would be to say y equals -2 plus or minus. Now, if I factor out a 9, and then I can take the square root of 9, outside of the radical, the 9 becomes a 3, correct? So you would say 3 times the square root of, and then you're factoring the 9 out of these pieces. So it's a -x squared plus 2x plus 15, I believe, and all over 4. That's another option. And these are all equivalent. It doesn't matter which way you type into the calculator. They're all going to be equivalent as long as you type them correctly. Now, my directions were to graph this, yes? If my goal is to graph this, how do you show me that you graphed it?
Show you the graph.
Yeah, you graph it, and then you're going to sketch me a graph. So if you haven't already graphed on the calculator, do that. Don't know if you did it right.
Would it actually make a difference if you put -2 or 2 up front?
Yes, it has to be a -2 up front. It doesn't have to be up front, but it has to be a -2.
Right.
Okay, so you can ignore my y3 and y4 there, and 5, because I was trying to save and not have to retype them in, but okay, so there's my y1 and y2. -2, and I use the preferred version where it's the square root on top. So square root of -9x squared plus 18x plus 135 all over 4. And when I graph this, what shape are you guys getting? Did I just hear football? My morning class said football, so
Ellipse.
officially it's a what?
Ellipse.
Ellipse? I wasn't sure what you said there.
I
so.
said eclipse.
Who was that yesterday? Was that you or was that someone else?
That's Carly.
Okay. So the whole ellipse versus eclipse question in this class yesterday. But okay, so you should be getting an ellipse, a football looking thing. Now, in my mind, ideally, it's graphing in 2 pieces. I would think if it's done correctly, that the calculator would at least make it symmetric pieces. And they're kind of lopsided, which does make me think that we've graphed it wrong, but here's the deal. We are all getting the same thing. Okay, and I've checked, So it does kind of graph asymmetrically or not symmetrically. I'm not exactly, that's just graphing failure. We did discover this morning, if you go and do a zoom square, so you make your screen square instead of rectangular, if you do a zoom square, it looks more symmetric. And it looks a little shorter. So if you do a Z5, here, if you look, your tick marks are all equally spaced. And it looks a little bit more symmetrical there. Okay. So you should be getting an ellipse. And here's the deal, guys. When you try to graph this, you're sketching me a graph. It doesn't have to be precise. But here are the things I'm kind of looking at. Is okay, it looks like it goes through about 1 on the y-axis. It looks like it goes through approximately -2 on the x-axis. If I try and guesstimate where that left end is, maybe -3, -2. Are you kind of seeing what I'm doing here? I'm just trying to get some key points. Where it crosses axes and maybe your end points. Looks like it crosses through -5 on the y-axis. Note it does go a little bit lower than that. See if I go over to positive x-axis. Is that a +4 maybe? And then maybe my other endpoint is about 5, -2. Okay, I just went through and grabbed some key points that I can then connect in an attempt to show you something that looks like a potato, not a football, not an ellipse. That is not a very good picture, but just goes to show, you know.
Is it supposed to connect?
Yes, it does. In reality, it does connect.
Okay, so why does it not?
It's the graphing calculator. Just graphing calculator failure that it's not able to connect them.
So if they don't connect, like on the calculator, we need to connect.
Yes, you need to assume that they do connect. Okay, if it's a parabola in 2 pieces or a hyperbola in 2 pieces, you need to assume, ellipse or parabola. You need to assume they connect. Okay, and that's a key thing that, you know, when I'm grading these, if you don't connect them, I'm going to go with you don't really understand what your graph is, and I'm not going to give you that full credit. I'm looking that they do connect, okay, of course, unless it's a hyperbola. Yes?
So one thing that I just noticed, if you try and graph it with the first answer that you showed, yes, it does not work.
It does.
It gave me a syntax error.
You typed it in wrong.
I do.
It worked.
It works.
What?
Did you use a negative or a minus instead of a negative?
I promise you that I had it in.
Oh, you don't have it typed in anymore, do you?
Yeah, I just changed it. But
Okay. It works, I promise.
Try again.
I'll try it one more time. But I promise you, the first time that I did it, it was like, no.
I'm going to promise you that you can type
I
in
promise you it works.
any 3 of these forms correctly, and you will not get syntax error. They will work. But all it takes is one little misstroke, and you can get a syntax error. The big thing I would say is -1 is supposed to be negative, -1 is supposed to be minus. Those are the 2 things. So, okay, I'm ready to move on to B.
Are we also doing C today?
We are. We gotta get moving. Now. Okay. B is short. Okay. As you look at B, 2xy minus 9 equals 0. What do we have in the way of y terms? We have one y term. It's 2xy, so basically there's a y to the first in there. So go back to your middle school math schedule, or math steps, and solve. How do we solve for 2xy? Well, the first thing I'm going to probably do is to add the 9 over. So now I have 2xy equals 9. How do I get y by itself? If it's 2 times x times y, we're going to divide by 2x. So if I divide by 2x, I now have y equals 9 divided by 2x. And that's your graph. Graph away. See what you get. Did it succeed or fail this time?
I guess this time it worked. I don't know what I did differently, but I promise you that I had both the same thing.
I'm going with you put a minus out in front of the 2 the first time through, maybe.
That's what I put the
So
negative
it's a
and then I
hyperbola?
tried a minus and it still didn't work.
Okay, so what is this 9 divided by 2x thing?
It's a hyperbola.
It is a hyperbola. And let's see. Oh, well, okay. I guess it won't really matter. Mine is still on Zoom 5, the Zoom square instead of the standard, but it should look about the same for this one. You get a basic hyperbola in first and second quadrants, right? First and third, oh my goodness.
How do the quadrants go from?
I just drew in 1. 2 is to the left. I'm drawing in 3, and 4 is bottom right. Basically, 1 is top right, and you go counterclockwise.
Wait, what did you say? Give us a syntax here.
If you put a negative, if you put
You shouldn't
not a
forget-
negative, a
Now,
minus sign.
And I will say on this one, the 9 over 2x, I would encourage you to use your fraction bar and put 9 on top, 2x on bottom. If you do the division sign without a fraction bar, you're going to have to make sure you put 2x in parentheses. It's going to have to be 9 division bar, 2x in parentheses.
Yeah, that's syntax.
I used the fraction bar and I did that.
Looks like it.
And then I started drawing it out.
You might have added like a plus sign or something, because I did that earlier when I was graphing something.
Down in white 8, you have that. So,
There's another
I don't, yeah, it's that chunk that's causing here.
Okay.
Because it's graphing the first equation,
and then doing whatever.
and then it's trying to graph that other and saying, what is this graph?
Yeah, I don't know. I didn't even realize it went further. Okay, thank you.
That's why I hit go to, because I wanted to see what it took me to. So, okay. We are full of syntax errors today. Are we ready for C? C's the biggie.
Yeah, I was trying to do it, but I didn't understand.
Okay. Now, I'm going to, if you guys have B, I'm going to erase B so I can move my graph up and use this whole space for C because I need space. So I'm going to move this up, give a C, and now I'm going to erase this business. Okay, we ready? As we start looking at this one and start trying to think what we want to do here, my question to you is, what do we have in the way of y terms?
Does
it-
X work?
Anything that has a y in it.
There's 4xy, 4x squared, and
The-
negative 91.
Okay, there's a 4xy, whoops, a 4y squared, a negative 90y. So if it was just y squared, or just the y to the first, like the xy and the 90y, we could solve. If there was y squared and there was y, we could complete the square. Because there's y squared and y and xy, we're going to take a different approach. We're going to do something crazy, and we're going to use the quadratic formula to solve this. Okay? Now, when we were trying to solve something using the quadratic formula, we need to be able to find our ABCs, right? And when we need to find our ABCs, we would always think ax squared plus bx plus c, except I'm not solving for x right now, am I? What am I trying to solve for? Y. So the form I'm going to try and get this in is ay squared plus by plus c equals 0. That's what we're going to work towards, and I'm going to lead you through it step by step. Okay, it's a little different, definitely. Meaning, we're first going to start, we're going to put any y squared terms together, anything that has a y squared. Then, we're going to group anything that has a y to the first. And then, we're going to group all the leftover pieces that didn't have a y squared or a y. Okay? So, what do we have first? In terms of y squared terms, we have a 4y squared. Do we have anything else that has a y squared? No. So we have 4y squared. Okay? Plus. What do we have in the way of y to the first? There's the minus 90y. And 4xy has a y to the first in it, correct? So we're going to use both of those. We're going to kind of lump them together. So I'm going to say plus 4xy minus 90y. Those are my y to the first terms. And then everybody else I haven't used. So basically everybody that did not have some kind of y in it, which includes x squared minus 30x and plus 450. And of course my equation still equals 0. So what I've done here, here's my y squared term. Here are my y terms, yes? We're going to have to talk about what the coefficient for y is. And then this business right out here, that whole thing is going to be my c, because that's all of my non-y terms. Normally we say constants, but we have x's and y's here. So let me rewrite this out one more time before we do our quadratic formula. When we talk about 4y squared, what is a? Excuse me. A is going to be what? 4. Okay, that's not the place I'm concerned about. Y to the first. What is our coefficient for our y to the first terms? And so what I'm going to suggest here is factor out the y. If I factor out the y, what's the remaining piece there? If I factor out the y, there's a 4x and a minus 90. So I'm going to write, I'm actually going to put 4x minus 90 in parentheses, and I'm actually going to put the times y afterwards, trying to lead you to see that this 4x minus 90 is your coefficient of y, which makes this our b value. A is what's in front of y squared. B is what's in front of y, or in this case, all the y's. And c is all the non-y's. So this x squared minus 30x plus 450, that whole thing is going to be my c value. Okay?
So is that like an equation you just have to remember?
Well, basically, I mean, it's just setting it up with the idea of ay squared plus by plus c, just like you would if you were trying to do ax squared plus bx plus c. So it's just, you know, I look for y to the seconds. These were y to the first, and these were non-y's. Now, do we know our quadratic formula? Officially, instead of x equals, I'm going to say y equals negative b plus or minus square root of b squared minus 4ac all over 2a. Because that's what we're getting ready to do, but with my big old monstrous ABCs. Okay? I told you we were doing something a little crazy, didn't I? I didn't say it was a piece of cake easy. I never tried to mislead you there. Okay, quadratic formula. Here we go. I'm solving for y, so I'm saying y equals negative b. If b is 4x minus 90, what is the negative of 4x minus 90?
Negative 4x plus.
Good. Negative 4x plus 90. Plus or minus the square root of b squared. So I'm going to write that as 4x minus 90 quantity squared. So there's b squared minus 4 times a, which is 4, times c, which is x squared minus 30x plus 450, all over 2 times a. So 2 times 4. I just plugged it in. I promise it's not, I didn't do anything fancy with that step.
So we don't have to like work it out.
Well, we are going to work it out a little bit. I said with that step, I didn't do anything. And I mean, that was, we'd already found our ABCs. That was kind of our hard part. Right here, I just plugged them into what we know is a quadratic formula. I guess technically, could you plug this mess into the calculator? Technically, yes. I'm not sure I encourage that at this point because there's a lot of typing to do and you'd have to type it twice. So I would encourage you to do a little bit of cleanup first. And the main cleanup I'm going to work with is under that radical. So the negative 4x plus 90 is good to go out front. Plus or minus. Now, on this square root, okay, yeah, we're going to square 4x minus 90. And technically, how do I have to square 4x minus 90? We have to FOIL that. Can you FOIL with me? 4x times 4x, if I'm FOILing here, 4x times 4x is going to be 16x squared. Then if you distribute your 4x to the other negative 90, 4x times negative 90 is going to be negative 360x. Those would be your outsides. Your insides are also going to be negative 360x for a negative 720x. That was a prank call, I take it. Okay. And then you have to FOIL your last piece. Hello? I do. Can I do it right at the end of class? Okay. Bye. Remind me about that phone call. Okay. Last piece, negative 90 times negative 90 is plus 8100. That's the FOILing piece, right? Now, right here, it's 4 times 4, which is 16. It's a negative 16. Can we now take the negative 16 and distribute it to our 3 pieces over here? So negative 16 times x squared is going to be minus 16x squared. Minus 16 times minus 30x plus 480x. And minus 16 times positive 450 minus 7,200. And this is all over 8. All of that mess, and we have a nice, neat 8.
It's a lot of numbers.
It is. Now, but look under the radical. One more step before it is a what I would call graphable. Can we do some serious cleanup here under the radical?
Yeah.
I would strongly encourage it. I would say negative y equals negative 4x plus 90 plus or minus. What do you notice?
16x squared canceled.
16x squared minus 16x squared. Gone. Negative 720x plus 480x are like terms. And that's going to be negative 240x. 8100 minus 7200 is plus 900 all over 8. This would be a good thing to graph. I can show you one way to simplify it, which is just good to know. But this is what I would call graphable at this point. Okay? The one thing that could simplify, guys, under the radical, and I want to show you this so you can kind of see how it works out, but you wouldn't be required to do this. Under the radical, 240 and 900 have a perfect square of 4. Is there something bigger? No, I think it's just 4. If I factor out that 4 and then take the square root, we can do a little bit more simplifying here. So let me show you. It's negative 4x plus 90 plus or minus. Okay, if I factor a 4 out under the radical, when I take that out of the radical, the square root of 4 is 2. If I divide each of those by 4, it's a negative 60x plus a 225 all over 8. And I have a reason for showing this. If you look at every piece of this problem, the 4, the 90, the 2, and the 8 are all divisible by 2. Okay, so this guy, this guy, this guy, and this guy. They're all divisible by 2, which means the simplified version of this is dividing each piece of the puzzle by 2. So negative 2x plus 45 plus or minus, and then that radical is just the square root of negative 60x plus 225 all over 8 divided by 2 is 4. That is probably your most simplified version. But again, I am happy with the previous one. Have you looked at the graph yet? Some of you have, I know. What shape did you get?
I don't know what it is.
Yeah, it's like a.
Is it no ellipse?
Why do you not know what shape it is?
Well, you have to zoom out.
Okay. Because it's taking forever. If you're just on a 10 by 10 screen, you just have part of the graph. Obviously, it looks above, so you need to do a zoom out or adjust. What I did on my window this morning is I know it's all above. I changed my Y-min to 0 and made my Y-max 20. And if I regraph that, you have a better visual of what it is. It's at a funky angle, if that helps. It's a parabola at a funky angle.
It doesn't connect?
It does connect. Again, it's like the ellipse earlier. The graphing calculator is not going to connect those two pieces precisely. Okay? So it is just that. I find this one hard to graph. I think. Let's see. Those are the numbers I remembered from this morning. It looks like it crosses through the y-axis about 7.5-ish, about 15. Looks like it goes over about 4 to the vertex somewhere over there. I find this a hard one to graph because it's hard to get it happening. Well, I don't have the right angle there exactly, do I? But it's doing something like that, right?
Yes.
Would it graph faster if we used the most simplified version?
I don't, not necessarily. It's worth a shot to try, but I don't necessarily think so. Okay. You have, I think, 6 graphs. They're not all like this, but there might be some like this. Okay? So your job is to do the homework. Page 618, 2 through 12 evens, 43 through 52 all. Keep in mind, I won't check it until Thursday. I'm not here tomorrow. Or at least that's the current plan. Now, The other thing, so tomorrow, it's a work period. One thing you can work on is that. I'm also going to go ahead and have the Chapter 8 review worksheet ready to hand out. So you can start looking at that. We only do the first 4 lessons in this chapter. So this will be it. Okay? Okay.